Hello everyone and welcome to this new class. We're going to continue with what we learned in the last class about the law of one price. You remember I told you that was a quite old theory, and this is a new theory. What we are going to learn today is a bit different, and this is an improved theory, but the basics or the base comes from the law of one price theory. So let me start again with kind of asking what you think about uh, 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 mm, like the outcome of the last class. I think you should remember that inflation plays a huge an important role in deciding the exchange rate, which currency is going to get depreciated or reappreciated. So we need to be, or appreciated, sorry. So we need to be careful with that. We need to be careful considering inflation as something important. But inflation is not the only thing. Is there anything else apart from inflation that might affect an exchange rate? And the answer is yes. And can you define that concept that also affects an exchange rate? You might tell me that political issues are important, that economy is important, that the perception of consumers and producers is important. All of those things are important. And if you can put all of these words into one concept, I will say that that concept is risk. Risk is the other important concept, right? And if we put together inflation and risk in one macroeconomic variable, what do we get? Because inflation is one economic variable by itself, right? And risk can be measured somehow. So if we mix inflation and risk, what do we get? We get the interest rate, because the interest rate is the one that gets, or that at least tries to reflect inflation and risk. And being more specific, this is the nominal interest rate. The nominal interest rate is the one that has both inflation and risk, because maybe you remember that risk is reflected in the real interest rate. The real interest rate is the interest rate, but the one without inflation. Nominal interest rate is the one that you see on newspapers, on the websites, things like that. Nominal, that's the interest rate that you read. And nominal interest rate includes inflation and risk. Here in the presentation, we have that it includes risk and it includes inflation. When we multiply rates, we need to add one. I hope you remember this from financial math. 1 plus the rate, 1 plus inflation is the nominal rate. It means that real rate plus inflation is nominal rate. So remember, real rate doesn't have inflation. Nominal rate has inflation. And again, this new theory also has some assumptions that might not be real or might not be true. And this is assuming efficient and open markets. I know that this is quite unrealistic, but at least it's better than the previous one, because in the previous one, we assumed that we had a product that we could buy anywhere and there were no transaction costs, things like that were impossible to achieve. At least in this theory, we have that efficient and open markets, that the real rates reflect the actual risk. So it's not entirely true, but at least we can work with that. And this theory, although it's not perfect, because not there are theories are not perfect. At least this perfect won a Nobel Prize, so it's kind of proof of some quality. Let's continue. So if we use, or if we assume that the differences of interest rates can determine how the currencies will behave, similar to inflation. You remember, like countries with different inflations, their exchange rates will tend to do something like this, right? If you can see in the video, it will tend to do something like this, like they will separate. In here is the same, but instead of inflation is a difference on interest rates. So if we follow that logic, we are going to come up to this formula, because in this formula, we are going to use the interest rates, the nominal interest rates, and we are going to do exactly as we did in the previous one. In the previous example, in the previous formula, sorry, from the absolute relative PPP, we had inflation, but in here, we don't have inflation, we have the interest rate. So let me tell you the three differences from this formula to the other formula. In this formula, we are calculating the, we are trying to forecast the exchange rate of the Swiss franc and the dollar, right? So in here, we also have time. This 180, this equals time. This 180 is time. So time in this case is going to be expressed on days. And this is something different, right? Maybe you remember from the previous formula that time was in years, now time is in days. So if you have one year, we're going to use 360. I will explain why 360. If we have half a year, 6 months, then 180, 2 years, 720. So we keep that logic. Why 360? Quick parenthesis. For two reasons. One is that it seems that in average around the world, there are 5 holidays in like Christmas, New Year's Eve, New Year's Day, I don't know, Independence Day from different countries, whatever. So in average, there are 5 holidays in each country. Some countries have more, other countries have less. So they say if we cut the holidays, we get 360. And the other reason is because 360 is more practical than 365 when we do math. So that's why 360 will be 1 day. So in this formula, days are in days. Sorry, T are in days, or T is in days. The other thing is that we are going to use the interest rate and not inflation, right? In the other one, we use inflation. And again, we have the same thing. This I, Swiss francs, is because Swiss francs is on top. That means that's home, right? I hope that's clear. And the final thing is that if you check this, we are using the formula of simple interest, right? In the other one, we use compound interest. That's why we had the exponent. Now we don't have exponent. Now we have simple interest. So that might be the last difference, simple interest. So that's the final thing, right? Like the final point. So if I solve all of this, you can do it in your notebook or in Excel. If I have this data, it means like the spot rate is 1.48 Swiss francs per dollars. That's my spot. The time is 90, so 90. And the percentage of the Swiss franc, the interest rate of Swiss francs is 4%. That's here, 4%. And for dollars, it's 8%. Then you do all of this thing, and the result, I don't know where's the result, where it is. I don't know where it is, but the result, well, you can do it in the next video. But you should remember, again, be careful with what you do. First, do this, then multiply, then do this, multiply, and then add up 1, then divide once you add up 1, and then you multiply times 1.48. So just be careful on that. I think it's very easy. I think it's not worth putting too much attention in here. What's interesting from this is, as you can see, we don't call this S anymore, spot, as previously. We call it, we use an F for the word forward. And why forward? This formula has been so successful that it's the one that people use in practice to calculate the price of forwards. We're going to learn this. We're going to learn about this in the third partial, but that's actually what people use this formula for, to calculate the price of forwards. So that's why we call it F as in forward or future. In this case, we will say it's the same, forward or future, for only for this exercise. So that's why we call it F. It's not S anymore. So if we do all of this, we will get the fair price for a forward or a future. But now I will teach you, and this is something very interesting. I will teach you how you can make arbitrage using forwards. So now, you remember triangular arbitrage? Now we're going to jump into something different. Instead of triangle, now we'll have a rectangle. So why rectangle? Because now we are considering time too. So we're going to move between countries, but also through time. So we're going to make an investment. So in the next video, I will explain that the strategy is called the covered interest arbitrage. And then after that, I think you will just practice. And in the next class, I'm going to explain another complication to the covered interest arbitrage.